Walk into a house with a struggling air conditioning system on a hot afternoon, and you can usually feel the problem before you ever touch a tool. The air feels heavy. Certain rooms are noticeably warmer than others. There may be a stale or musty smell coming from a bedroom, basement, utility room, or return vent. The homeowner might tell me, the air conditioner is running, but the house still doesn't feel comfortable. My name is Mike, and I have worked in heating, ventilation, and air conditioning for years. Today, I want to talk about a popular homemade cooling idea involving activated charcoal, water, and a fan. You may have seen people claim that a shallow tray of wet charcoal can cool a room, remove moisture, eliminate odors, and replace an expensive air purifier. Some parts of that idea come from real science. Other parts are exaggerated, and a few parts could actually make the air inside your home worse if you use the setup incorrectly. So, I'm going to explain what activated charcoal can realistically do, what it cannot do, and how an HVAC technician would approach the same problems safely. Because when you understand how heat, humidity, airflow, filtration, and ventilation work together, you can make your home much more comfortable without wasting money on tricks that sound better than they perform. Let's start with the cooling claim. Moving air across a wet surface can absolutely create cooling. That process is called evaporative cooling. Your body uses the same principle when you sweat. Moisture reaches the surface of your skin, the water evaporates, and that evaporation carries away heat. A traditional swamp cooler works in a similar way. It pulls warm outdoor air through wet pads. As water evaporates from those pads, the air temperature drops before the air enters the building. That is legitimate cooling technology. But there is an important detail that many homemade demonstrations leave out. Evaporative cooling works best when the outdoor air is hot and dry. When the humidity is already high, the air cannot absorb very much additional moisture. That means less water evaporates and much less cooling occurs. This is why evaporative coolers can work well in dry parts of Arizona, Nevada, New Mexico, and inland California, but perform poorly in places where summers are hot and humid. If you live in Florida, Louisiana, or another humid climate, adding more moisture to the air may make the room feel stickier rather than more comfortable. Air temperature is only one part of comfort. Humidity matters just as much. A room that is 76 degrees with controlled humidity can feel better than a room that is 72 degrees with excessive humidity. Your central air conditioner does two jobs. It removes heat and it removes moisture. A wet tray placed in front of a fan may create a small temperature drop directly in the airflow, but it is also adding water vapor to the room. That is not the same thing as air conditioning. Now let's discuss the charcoal. Activated charcoal, also called activated carbon, contains a network of extremely small pores. Those pores create a large amount of surface area. Certain gases and odor-producing compounds can attach themselves to that surface through a process called adsorption. Adsorption is different from absorption. With absorption, a material soaks something into its internal volume, like a sponge. With adsorption, molecules cling to the surface. That is why activated carbon is used in some air filters, range hoods, water filters, respirators, and odor control products. It can be helpful for reducing certain smells and some volatile organic compounds. However, activated carbon is not a complete air cleaning system. It does not replace a proper particle filter. It will not reliably capture dust, pollen, pet dander, mold spores, or smoke particles unless the system also contains filtration designed for those contaminants. For airborne particles, you normally need a mechanical filter with an appropriate efficiency rating. In a residential HVAC system, that may be a pleated filter with a MERV rating suited to the equipment. For portable room filtration, that may be a true HEPA filter combined with activated carbon. The HEPA portion catches small particles. The carbon portion helps with some gases and odors. They perform different jobs. That distinction matters because people often buy a thin carbon sheet and expect it to clean everything in the air. It cannot. There is another issue with soaking activated charcoal in water. Dry activated carbon is generally used for odor and gas adsorption because its pores need to remain available. When you saturate those pores with water, you may reduce the amount of available surface area for other compounds to attach to. In other words, wetting the charcoal may help create an evaporative surface, but it may interfere with the carbon's ability to capture certain odors. You are trying to make one material perform two different jobs, and those jobs do not necessarily work well together. Standing water also creates another concern. Any container that stays wet inside a warm room can become a place for bacteria, slime, or mold to develop. That risk increases if the water is not changed, the tray is difficult to clean, or dust and organic material collect in it. Then the fan can move those odors or biological particles into the room. As an HVAC technician, I would never recommend leaving a dirty, wet tray in front of an air intake and assuming it is automatically improving indoor air quality. If you experiment with any small evaporative setup, the container and wet media need to be cleaned regularly. You should use clean water, avoid stagnant water, and stop using it if you see slime, discoloration, or mold growth. And never place loose charcoal, wet material, or an improvised filter inside your furnace or air handler unless the equipment was designed for it. You can restrict airflow, damage the blower, cause water to leak into the cabinet, or create an electrical problem. Restricted airflow is one of the most common problems I encounter. Homeowners sometimes install an extremely restrictive filter because they believe a higher number must always be better. But if the ductwork and blower are not designed for that resistance, airflow falls. When airflow falls, the system may cool poorly. The evaporator coil can get too cold and freeze. The furnace can overheat during heating season. Energy consumption may rise, and the equipment can wear out sooner. Filtration must match the system. More filtration is not automatically better if the blower cannot move air through it. Now, suppose one room in your house feels hot, stale, and uncomfortable. Before buying charcoal or building a homemade cooler, here is how I would diagnose it. First, I would check whether enough conditioned air is reaching the room. Is the supply register fully open? Is furniture blocking it? Is the duct disconnected, crushed, leaking, or undersized? Is the room far from the air handler? Does the airflow feel noticeably weaker than it does in other rooms? A disconnected duct in an attic or crawl space can dump expensive conditioned air outside the living area. Meanwhile, the room receives very little cooling. No tray of charcoal will solve that. Second, I would look at the return air path. Air cannot enter a room effectively unless air can also leave. A bedroom may have a supply vent, but no dedicated return. When the door closes, pressure builds inside the room. That pressure can reduce supply airflow. A proper return vent, transfer grill, jump duct, or sufficient door undercut may improve circulation. Again, that is an airflow problem, not a charcoal problem. Third, I would measure temperature and humidity. You can purchase a basic digital thermometer and hygrometer for relatively little money. Place it in the problem room and compare the reading with the rest of the house. If the humidity regularly stays above roughly 60%, adding more evaporated water is probably the opposite of what you need. High indoor humidity can make the home feel warmer and may contribute to condensation, odors, dust mite growth, and mold problems. Possible causes include an oversized air conditioner that cools too quickly, short cycling, duct leakage, bathroom exhaust problems, moisture entering from a crawl space, or outdoor air leaking into the house. Fourth, I would inspect the filter and indoor coil. A clogged filter reduces airflow. A dirty evaporator coil also reduces airflow and heat transfer. If the coil is covered with dirt, the system cannot move heat efficiently. You may notice weak airflow, long run times, higher energy bills, or ice forming on the refrigerant lines. Replace disposable filters according to the manufacturer's recommendations and have the equipment inspected when performance changes suddenly. Do not attempt to clean an internal coil with random household chemicals. Some cleaners can damage the coil, create fumes, or push contamination deeper into the system. Fifth, I would check ventilation and exhaust. A stale room may not simply need colder air. It may need fresh air or better removal of pollutants. Bathrooms should have exhaust fans vented outdoors. Kitchen exhaust should also discharge outdoors when possible. Dryers must be vented properly. Combustion appliances require safe venting. If odors are coming from a crawl space, attic, garage, or mechanical room, the source needs to be identified. Masking an odor does not correct the condition causing it. This is especially important with animal areas. Activated carbon may help reduce some smells near a litter box, kennel, or small animal enclosure, but it does not replace cleaning or ventilation. In a chicken coop, ammonia develops as waste breaks down. The correct solution is regular litter management, adequate ventilation, moisture control, and enough air exchange for the number of animals in the space. A carbon filter may serve as an additional odor control layer, but it should not be treated as the primary safety system. If the smell is strong enough to sting your eyes or nose, the animals are breathing it too. That means the enclosure needs more attention than a tray placed near a window. The same principle applies inside a house. When you smell mustiness, sewage, chemicals, burning, or persistent dampness, do not assume the odor is the entire problem. The smell is often a warning sign. A musty odor may indicate a plumbing leak, roof leak, wet insulation, dirty drain pan, clogged condensate line, or microbial growth. A burning smell may involve an overheating motor, electrical connection, belt, heater, or accumulated dust. A sewage odor may involve a dry trap, venting problem, or damaged drain line. Activated carbon might temporarily reduce what you smell, but reducing the smell could make it easier to ignore the actual source. That is why good indoor air quality starts with source control. Remove or repair the thing producing the contaminant, then improve ventilation. Then use filtration or purification as an additional layer, not the other way around. There is also a dangerous instructed that wet charcoal in a room will remove oxygen from the air. A small tray of wet activated carbon is not going to meaningfully deplete the oxygen in an ordinary room simply through normal absorption. However, that does not mean sealed rooms are safe. Any occupied room still needs proper ventilation, especially when it contains animals, fuel-burning appliances, chemicals, or other pollutant sources. Carbon monoxide is the gas that homeowners should take especially seriously. Activated charcoal in a tray is not a substitute for a carbon monoxide alarm. Every home with fuel-burning equipment, a fireplace, or an attached garage should have working carbon monoxide alarms installed according to local requirements and manufacturer instructions. Check the batteries and replace alarms when they reach the end of their rated service life. Carbon monoxide has no reliable smell. You cannot judge its presence by whether the room seems stale. Now, can you still use activated carbon around the house? Yes, as long as you use it for an appropriate purpose. A carbon-based filter can help with certain odors. You can use a portable air cleaner that combines HEPA filtration with a substantial amount of activated carbon. You can use carbon inserts designed for a specific appliance. You can place a dry carbon odor absorber in a ventilated location and replace it according to its instructions. The word substantial matters. Some inexpensive purifiers contain only a thin black sheet with very little carbon. That may provide limited odor reduction, but it will become saturated quickly. A purifier containing more carbon generally has more capacity for gas and odor adsorption, although performance still depends on the contaminant, airflow rate, contact time, and product design. Activated carbon also does not stay effective forever. Once its available surface becomes loaded, its performance drops. Setting used carbon in sunlight may dry it and reduce some moisture-related odors, but it does not reliably restore the material to its original adsorption capacity. Industrial carbon regeneration uses controlled high temperatures and specialized processes. For home use, you should generally replace carbon media according to the product instructions rather than assuming sunlight makes it new again. So, here is the practical bottom line from an HVAC technician. A fan blowing across water can produce some evaporative cooling, especially in a dry climate. Activated carbon can reduce certain odors and gases when it is used correctly, but soaking loose carbon in a tray does not create a homemade air conditioner and air purifier that performs like professional equipment. In a humid climate, it may add unwanted moisture. If it is not cleaned, it can become unsanitary. If it is placed inside HVAC equipment, it can restrict airflow or cause damage, and it will not correct duct problems, refrigerant issues, dirty coils, poor ventilation, excessive humidity, or the source of a serious odor. For a hot room, begin with the basics. Make sure the register is open and unobstructed. Check the air filter. Compare the airflow with nearby rooms. Keep blinds or curtains closed during the hottest part of the day. Seal obvious air leaks around windows and exterior doors. Use a ceiling or portable fan to improve air movement. Confirm that bathroom and kitchen exhaust fans work properly. Measure the humidity. And schedule an HVAC inspection if the system runs constantly, freezes, produces unusual smells, makes new noises, or cannot maintain the thermostat setting. A qualified technician can measure static pressure, temperature split, blower performance, refrigerant operation, duct leakage, and humidity. Those measurements tell us what the system is actually doing. We do not have to guess. I understand why homemade solutions are appealing. HVAC repairs can be expensive. Electric bills are rising. People want a simple way to make one uncomfortable room feel better without replacing an entire system. And sometimes a low-cost improvement really does help. A better return air path, A sealed duct connection, clean filter, repaired exhaust fan, shaded window, or properly sized portable air cleaner can make a noticeable difference. But the best solution is the one that matches the actual problem. Cooling, dehumidification, ventilation, particle filtration, and odor control are separate functions. Some equipment performs more than one of them, but no $7 tray performs all of them well. So, before copying the latest cooling trick you see online, ask yourself 4 questions. Is my problem temperature, humidity, airflow, pollution, or a combination? What is creating the odor or discomfort? Am I removing the source, or am I only covering it up? And could this homemade setup add moisture, restrict airflow, or create another problem? Those questions can save you money and protect your equipment. They can also help you recognize when a simple adjustment is enough and when it is time to call someone with the proper instruments. Let me know in the comments what problem you are dealing with. Is one bedroom always hotter? Does your house feel humid even while the air conditioner is running? Do you notice a musty smell when the system starts? Or are your energy bills climbing even though you have not changed the thermostat? Those details often point us toward the real cause. And remember this, comfortable indoor air is not just cold air. It is clean air moving at the correct rate, with heat and humidity under control. Get those pieces working together, and your home will feel better without relying on a trick that promises more than it can deliver.